Hello everyone, I am Kalyan Prasad. I am an Eclipse JDT co-lead and a committer on platform. I work for IBM. Welcome to the talk on walking through the Eclipse IDE tooling support for new Java versions. I'll be demoing most of the examples, for which I'll be using 4.25 release, on which I have installed the Java 19 support. So the agenda of today's talk will be preview features that are available on Java 19, pattern matching for switch, record patterns, virtual threads, and a standard feature which is available from Java 18 onwards, that is code snippet support in Java API documentation. So first, let us start with pattern matching for switch. So traditionally, the switch was used for switching over constant values. So Java 17 had introduced pattern matching for switch on type objects, types. So now what has happened in Java 19, additionally along with type switching, we also have when clause that has been added, by which you can add patterns, additional patterns through which you can switch on for each case specific to a specific pattern within the object. For example, here I have case integer I, and then I have a when clause by which I can check whether the value of I is greater than 0 and only then go into the first case statement. Next, I have a second case statement where I have an integer j, which does not fall into the first category. So if the value of the integer j is less than 10, it comes to the second case. And I also have a default case. Then firstly, then you may be asking, why do I need to have a pattern matching if I can achieve the same thing by using if statements? The basic idea here is in using pattern matching for objects, you should cover all the cases extensively. By using if-else pattern matching using the by using if-else statement, you can actually miss some of the cases. But by using pattern matching, if you don't have a default case, for example, here, and if you have not covered all the cases, an error is thrown. Let us look at this with a demo. So now, for example, I have the same case here. I have a print string method where I have a case integer I. When I greater than 10, I print out the integer value. I have a case integer j. I print out the value. I have a case string s. I print out the value of the string. And I have a default case where I print out the value of the object. Now let us see if I don't have this default case, what will happen. I immediately get an error. I know you cannot see it, but I will read it out for you. An enhanced switch statement should be exhaustive. A default label is expected here. So this you will not get if you are using if-else statements. So static analysis is being done by the compiler, and given the error is given to you at the compile time itself. Now, for example, here you need to always have a break statement for each of these cases. Because, for example, if I do not have a break statement for integer case where integer is integer j, I get an error here saying that illegal fall through to a pattern. The basic reason, for example, here is if I have an integer j, and it should not go through the case where it is a string s, because it is not valid. So basically, for each of these cases, a break statement is needed. And you also can use the pattern matching for switch in a switch expression. As you can see here, I have a usage of when clause in switch expression, where I switch over an object O, case integer I. When I is greater than 10, I am using an enhanced switch expression here. So I don't need a break statement, it is implicit here. So now I have a second case where integer I, I am printing out the int value and a default object value. And I have a simple object called x here for the demo purpose. So what I am doing is, firstly, I am calling the print string method, which is using the switch statement for 30, 9, and hello as the inputs. And I also call convert to string, which is using a switch expression. And I use hello, 30, and 9 similarly. Let me run this. Run as Java application. So as you can see here, when I give 30 as the value, it goes to the case number in line number 8, and it prints out integer greater than 10 and the int value. And when I give the input as 9, it goes to the case that is in line number 11 and prints out the integer value. And when the string is given as input, it goes to line number 14 case and prints out the string value. So this is the example of pattern matching. Now let us go to the next preview feature, that is record patterns. What is if you look at the example here, the old way of using pattern instance of, for example, I want to print the sum of a point which has x and y coordinates. So I call O instance of point P, system.out.println, sum is equal to print.x, p.x plus p.y. Now the record pattern deconstruction allows you to directly refer to the record components in the record pattern x and y. The way to do it is here below. If O instance of point int x comma int y, you can refer directly to the record components x and y and print out system.out.println x plus y. So let us look at a live demo for this. So I'm having the same code that I have shown you as an example here. In the old case where I'm using pattern instance of, and in the second case of print sum, I'm using a if statement, O instance of point int x comma y, and print out using the record pattern, directly referencing the record components. And I also can use a switch expression. I also can use the same record pattern, which is a switch expression, as you can see here, case, point int x comma y, and print out using the record components x comma y that you have referred here. So I have made a main call in which I have called all the three functions. Let's see whether they yield the same result, which they should actually. Run as Java application. And as you can see, all the three of them yield the same result. Now let's go to a complex case of pattern deconstruction, record pattern deconstruction. So now I already have defined a point x comma y. Now I would like to define a colored point. So I define an enum which has three colors, red, green, and blue. And I have a colored point which takes one record component as a point and the other record component as a color C. Now I also define a colored rectangle which has an upper left corner for colored point and a lower right corner for colored point. Now let's see, I have a function called print upper left colored point for a colored rectangle as the input. So now I am using a deconstruction, one level of deconstruction as shown in the previous example, where I say R instance of colored rectangle, colored point UL, colored point LR, and I can directly call ul.c, the color of the upper left colored point. Now as you can see, I can also see all the functions that are available under ul because the binding has been resolved for the colored point and all the content assist is available here for the colored point here. But as you can see, I directly require only the color. So I can do further deconstruction of it. The colored point UL can be deconstructed to colored point P, and color C UL. And now directly I can print out the color C here. So further deconstruction of a record pattern is shown here. So, and if I also want to directly refer to the x coordinate of the point P, I can further deconstruct it. So here I have a function which is print x coordinate of upper left point with patterns. So now I have deconstructed the point P which is above into point var x comma var y, and I have printed out the value x. So now let's see, I have defined a colored rectangle here which has a colored point which is 5 comma 10 with a color red as the upper left corner, and I have a colored point with point 7 comma 8 and the color green as the lower right corner. Now if I call the function for the color of the upper left corner, for the first and the second calls I need to get red as the color, and for the third one the x coordinate of the upper left corner should be 5 as defined here. Let's see whether that happens. Run as Java application. As you can see, the color is printed correctly and even the upper left corner is printed correctly. So this is the example of pattern deconstruction in the record patterns. Let's move on to the debugging support for virtual threads. Now virtual threads are lightweight daemon threads, the scheduling of which is handled by the JRE scheduler, not by the OS. And now you look at it here, I have a normal thread. This thread 0 is a OS thread. And the virtual thread here is shown as system thread. So the difference can be seen very clearly in the debugger, that the system thread refers to a virtual thread and normal thread refers to a thread here. Let's look at an example in the debugger. Let us take a very simple case. Now I have here a runnable which prints out whether the current thread is a virtual thread, is virtual by using is virtual call, and else it prints out is a standard thread, and also prints out whether it's a daemon thread or not. So now at this point, line number 15, I am calling new thread, which is a normal thread, and call the start for the thread, after which I will call a virtual thread start. Let's see what happens when we debug. Debug as Java application. Let me remove the. So as you can see, first I have put a breakpoint at line number 16, if you cannot see. So let me go to the next line. Firstly, as you can see, a normal thread has started here at line number 16. Let's go and complete the normal thread run. And it gives a clear output saying that it's a standard platform thread, it is not virtual, and it is not daemon. Now let us start a virtual thread. As you can see, you have a system thread call here. Now this clearly says that this is a virtual thread. And let us debug this also. It should give the value here. As you can see, the output is very clear that it's a second thread is a virtual thread, is virtual is true, and is daemon is true. Now you'll have to be very careful, because while debugging virtual threads, each virtual thread will be mapped to a OS thread by the JRE scheduler. So for example, here when you are putting a breakpoint, you should be very careful. Let us look at one example where I am creating a simple task runnable where I have a number and a queue as an integer. I wait for 1 second and then thread.sleep for 1 second, and I put the value within the queue. So now here I have started 11 threads, for example, each thread with a virtual thread name, and at the end of them I print out system.out.println. Now if I have put a breakpoint here in line number 21 thread.sleep, what will happen? Let us have a look at it. Debug as Java application. So as you can see, the main thread has started, and as my processor is an octa-core processor, you will see that only 8 virtual threads have been scheduled here as of now. Let me run one of the threads, and now the next thread has started. Let me run the next thread. Next thread has started here. Let me run the next thread. Next thread has started here. So total 11 threads have already started, virtual threads. In no particular order, the output is done here. So so we need to be very careful where we put a breakpoint while running virtual threads. So this is an example of how virtual threads are supported in the debugger. So now let's go to code snippet support in Java API documentation, which is a regular feature in Java 18. So what is this exactly? Previously, if you want to add a code snippet in Java API documentation, there was a very tiresome process of adding HTML tags, code/code. Within that, you write your code snippet. And if you want to decorate some part of the code, you will need to, if you want to write bold some part of the statement, you will have to add b/b HTML tags, etc., etc. To make this easy, the code snippet support has been added in Java API documentation. For example, I have an inline snippet here called @snippet, very simple. And immediately after @snippet, you have to give a space and a colon and a new line, and you write your code that you need to be put in the documentation here immediately after that. Now here I have a simple code where I say system.out.println inline snippet sample. And if you hover over this, you can see that it shows the snippet here. let's have a demo of it. So now here I have a simple snippet tag, simple snippet as I showed in the example here. Now I have added a add snippet inline tag, and I have given the snippet here. Let me hover over this, and I can see that I see the snippet here. I can also see the same snippet even in the Java doc view. Now, if only adding the snippet code was there, we could have done with code/code also. But now if you want to add some decorators, there are 3 kinds of decorators that are provided in this for supporting the decoration of the code snippet. The 3 tags are at highlight, at replace, and at link. So the way to write these decorators is, now for example, I have a snippet code with highlightings, and I have defined a snippet tag where there are 4 lines. Is this visible to you? Yeah. So now I have hello. Okay. So I have 4 lines of snippet code here, in each of which I am doing a system.out.println. In the first case, I am doing an at highlight of a substring called inline snippet, and the type of highlighting is highlighted. And in the second case, I am doing a highlighting of a substring called inline snippet, and the type of highlighting is bold. In the third line, I am using a highlighting of the same substring, but the type of highlighting is italic. And in the fourth case, I am not using a substring, but I am using a regex, where I am searching for a string which is within double quotes, and the type of highlighting is highlighted. The way to define these define these decorations is by using single line comments. So each single line comment within a snippet code will be taken as will be looked for the decoration annotations, and those will be acted upon. So now if you look at the Java doc for this, system.out.println inline snippet is highlighted. In the second line, the inline snippet is bold. In the third line, inline snippet is italic. And in the fourth line, the regex that it matches has been highlighted. Now let's look at the Java doc for this. Let us generate the Java doc. Project, generate Java doc. So Java doc has been generated, as you can see. Now let me open the Java doc for this. Let us go to the first case, where we had a very simple snippet. As you can see, it is exactly the same here. The snippet, the way it is shown in Eclipse Java doc as well as here. Let us see the highlighting. And in this case also, the first line, the inline snippet is highlighted. In the second line, the inline snippet is bold. In the third line, the inline snippet string is italic. And in the fourth line, the regex is highlighted, which is the same as in our Eclipse Java doc. Now let's go to see how the at replace tag works. So now here is a sample snippet code with replacement. So for the same string, system.out.println, in the first case, I am replacing the regex inline snippet with a replacement called snip. And I am replacing in the second case, I am replacing the regex which is within any string within double quotes to a replacement called ... Let me look at this, and as I can see, in the first line, inline snippet has been replaced with snip, and in the second case, regex has been replaced with dot, dot, dot. The basic idea behind replacement is, when somebody looks at the code, you want to look at one part of the code. But for some reason, maybe for the sake of licensing issue, etc., you don't want the exact thing to be available in your Java doc. So you can provide this replacement string, and that part will be replaced with whatever replacement string you provide. Like for example, here dot, 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 and then that will be the Java doc that will be provided to the user to get a basic idea of how to use that snippet. But if somebody is looking at the code, they can look at the exact Java doc that is provided here. So let us see the generated replacement Java doc. So this is exactly the same. Inline snippet has been replaced with snip here, and here the whole string within the quotes has been replaced with dot, dot, dot. Now let's go to the @link tag, that is @link annotation that can be used here. Now this is a sample snippet code with link to definitions. So now here I have a system.out.println, and I have an instruction here saying that you link the substring system.out with system, the out call, the function called systemout. So let me see what happens. The generated Java doc looks like this, as shown below. I click on system.out here, and it takes me to the Java doc for the print stream Java lang system out. Let's see how the generated Java doc for the same thing looks in Java doc. And here also it is similar. You have a system.out which is linked. You click on it, it takes you to the print stream out. Now, this is not limited to only .java files. You can as well provide code snippets which are related to properties file. The example for this is here at snippet. I am saying the languages properties file. The reason I need to provide languages properties file is, in a properties file, a single line comment does not start with // it starts with hash. So to give that instruction for the Java doc to handle this, you need to provide the languages properties. When you provide the languages properties, any line which starts with hash, it looks for the decorators in that, at highlight, at replace, and at link, and this is acted upon. But if you look at it in a properties file, you cannot add hash at the end of a line. You will have to add, the hash should be in the beginning of a line. So how can it act upon a line then? So you end it with a colon. The instruction of colon means that this will be acted upon on the next line. So the at highlight option that is being provided should act on the next line, that is local.zip is equal to 94123. So that's what happens. The regex, which is a 0, any number between 0 to 9 has to be highlighted. 94123 is highlighted here. Let us look at the generated Java doc for this, and this is exactly the same as shown. Now, this is fine for single line, but how do I add the same decorator for a whole block of code? So to do that, an option has been provided called region. So when you are giving a highlighting option, at highlight, I can specify that a region starts from here. And until you encounter the at end tag, the region will be alive. So this at highlight option will be act upon all the lines until the at end tag is reached. So now, for example, line number 6 to line number 8 forms a region, and the highlighting of the substring inline string should act upon all these 3 lines. As you can see, all these 3 lines are highlighted here. Let's look at the generated Java doc for the same thing, and you will see that this is exactly the same that is happening here. So this is with inline snippets. What if you have very huge pieces of code I want to refer to? So what you can do is you have external snippets. You can refer to files that you need to add in Java doc, and when the Java doc is generated, the whole file content will be put in the Java doc. So let us go to the next external snippet example. So I have defined 2 snippet files. In a folder called snippet files, I have defined 2 files called snippet file 1 and snippet file 2. What I am saying is here is, I am having just println statements in this. I have a hello world statement in the line number 11, hello Java 1, hello Java 2, and hello Java 3 statements in 12, 13, and 14. And I have a highlight option that I have provided, and I have defined a region here, which ends with at end here. So the highlight region ends for 3 lines, covers 3 lines, and the replacements is covering 1 line. Now, how do I refer this file directly in another file as a Java doc? So I go to external snippet 1 class here. So I can say at snippet class is equal to snippet file / snippet file 1. The assumption that we make in Eclipse is the source folder for the snippets is SRC. So you give a reference from SRC, and you say that go to snippet files under SRC and snippet files 1. And the generated Java doc, if you look at the Java doc here, it adds the whole class that is snippet file 1, and it highlights this. So what the instructions that were given was, if you can see, highlight substring hello, type is highlighted, and in the replacement, replace out with in. And if you look at the generated Java doc for this, the Java doc that is shown in Eclipse for this is, hello is highlighted in the 3 lines, and the replacement has happened here. Out has been replaced with in the second line. Let's generate the Java doc for this also. Project, generate Java doc. To generate the Java doc for an external snippet, you need to provide the option here called snippet path. And you have to give, if you want to look at exactly how Eclipse is doing it, you need to point to the SRC folder, because the references of all the Java docs are related to the SRC folder here. So finish. So let me generate the Java doc for this, and you will see exactly the same thing here. The whole file has been put in as a Java doc, and hello has been highlighted in the 3 lines, and out has been replaced with in the second line. So now, for example, I do not want to refer to a whole file, but I want to refer to only part of the file. How do I achieve that? So to achieve that, the tag has been, an annotation has been provided called @start. So in a single line comment, give an @start annotation and define a region. Because you will have to refer externally to this, you need to give a name for the region, and only then can you refer to the part of a file using the region name. So @start region is equal to 1, and you are highlighting here substring hello in the first line, and in the last line you are highlighting substring Java and in italic. So let us see the generated Java. Let us see the Java doc that is shown here. You are referring to in the Java doc here, giving the file name snippet files / snippet file 2, and I am also saying this is the region. I do not want to show the whole file. I want to only show the region that is part of the file. So now I see that only those 4 lines that are contained within @start and @end will be shown in the generated Java doc. And in the first line, hello is highlighted. In the last line, Java 3 is italic. Let me look at the generated Java doc here. And you see the exact same thing. Only those 4 lines are selected. Hello is highlighted, and Java 3 is italic. Now similarly, even you can as well use the properties file to refer to in the snippets. For example, in external snippets, I have a message.properties file here. Local.timezone is PST, local.zip, and local.area code. And I directly refer to the file @snippet. File is equal to this. The generated Java doc, the whole content of the file is added here. And let me look at the generated Java doc here. You can see local.timezone is PST, local.zip is 94123, and local.area code is 415. This is exactly the same as shown in Eclipse. So these are few of the important links. Support for Java 19 on Eclipse 4.25 is available at the marketplace. You can try it out. If you want to directly use the Java 19 features, what's new in 4.26 M1? It already has Java 19 support. You can use the 4.26 M1 to check out how Java 19 works. And the example codes that I have used here, most of them are taken from the Java 19's example page that is available in eclipse.org, Java 19 examples. You can try out all these examples. Thank you. If you have any questions.
With the code snippets, is there also a possibility to do informal code?
I didn't get you. Yeah, tell me.
So with code snippets, is there a possibility to format the code, so with indentation, for example?
Yes, yes. The way you provide the indentation in the snippet code, that is exactly how it will appear. So I can show that to you in the demo. Now, for example, I can copy this same statement here. And you can see the indentation that comes. So that's the advantage. Otherwise, you need to do a lot of magic with the HTML tags. Instead, it's much easier here to do the same thing. Yes.
Hello. Can you tell the reason why the virtual threads are scheduled later if you put a breakpoint in them as you demonstrated? Because I would expect that they would all be scheduled at the same time and then hold all at the breakpoint.
By default, one virtual thread is associated to one OS thread. So based on the OS threads that are available, that's the way scheduling happens. You can change the default settings. If no other questions, thank you for attending the talk.